All right, I'm going to give you guys a few minutes to start this first proof on your own. Nothing new is needed for this proof. Nothing new. All right, good work. Good work, everybody. You guys, everyone noticed, I know some of you are finishing up, but you've shown me, you noticed this was an addition proof. I am getting bigger. I already have two quantities in the givens that I need to add together. Okay, so nice work. Any questions? All right, let's expand on what we know right now. And remember, I'm going to give you everything that I put up on the board on Thursday on a sheet of paper. All right, now we got to start talking about some angle facts. All right, some angle facts. First one and only one I'm going to give you today says all right angles are congruent. I know that makes sense to you guys, that because both, if angles are 90 degrees, of course they need to be congruent, but I need to show you how to properly put it into a proof and use it properly. So I'm going to let you guys go ahead, read through the givens in example one, mark your diagram with whatever markings you think you need, and then go ahead and do statement one with the givens. We should have a few markings on our diagram now. All right, so hopefully on this diagram here, we have the following. You have a right angle symbol at ACB. We have a right angle symbol there. I'm not even going to ask anymore because it should just be automatic. Perpendicular symbol means I form right angles where CD and AB meet. So hopefully you either have a right angle symbol at ADC or at BDC or both, because they are both right angles. Any questions about the markings? Now let's look at the proof statement. Take a look at the two angles I need to help me prove congruent. ACB, which what did I already mark there? A right angle. And congruent to ADC, which I already marked what there? A right angle. So the two angles I'm asking you to prove congruent are already right angles, so shouldn't they already be congruent? Yeah, and this is what we're gonna use. All right angles are congruent. But whoa, it's not a two-step proof. Right? If you want to tell me two right angles are congruent, you need to tell me in the statements that they are right angles first. How many angles have I told you are right angles in the statements right now? How many? Just the one, right? Angle ACB, just the one. You need to tell me the other one is a right angle. And guys, I don't care what's marked in your diagram. I don't grade your diagram. As beautiful as it may look, I don't care. Well, I had a right angle at 8. No, I don't care. It's got to go in your proof. So again, if you want to tell me two right angles are congruent in your proof before then, you have to tell me that they are right angles. The only one I've told you is ACB. What other angle do I need to tell you is a right angle? Angle. I told you ACB. I got to tell you ADC is a right angle. All right? You need to tell me the two angles you're going to say are congruent are right angles before saying congruent. Okay. Why though? Why is that one a right angle? We've used this reason before. Okay, Josh loves the definition of perpendicular, which I'm fine with. I use something else in class that I've been using, so I'm going to stay consistent, but definition of perpendicular, not going to bat an eye at. I use perpendicular lines form right angles. But if you want to use definition of perpendicular, I'm fine. All right, now take a look. I've told you ADC is a right angle, and I've told you ACB is a right angle. Now you can tell me in step 3 that they're congruent. But that has to happen in your proofs is, hey, you need to tell me they're right angles first before saying they're equal. Diagrams don't count. And then now here's our new theorem today. All right angles are congruent. So that is how I use this new fact theorem I'm giving you. Okay, we all right? Now it's time. It's time to take the board and mix them all up now. How many do I need? What's appropriate? What's appropriate here? So here we go. Go ahead. Same thing. Mark your diagram. Put all your givens in statement 1. Now we're going to start using a variety of the theorems I have up on the board. Just not one of them.
Can we start doing it?
No. I just want you to mark it. No, just mark it. Yeah, I wouldn't expect you guys to do this one. I do expect those markings, though, to be in the correct spots, right? All right, so I see it has right angles, so I know it's going to be something with the right angles. Again, we're very limited. Can we just take halves of equal quantities off the board here? All right, no shot, no midpoint, no bisector. Guys, what are we really down to now? What are we down to? Addition and subtraction. That's what we're down to. It's not halves of equal quantities, so it's probably going to be addition or subtraction here. All right, take a look. I've marked the right angles and the congruent angles ABC and FGE. These angles need to be congruent now. DBC and DGE, look where those angles are. Look what you marked, and look at the angles I need. What do you think here? Bigger, smaller, addition, subtraction. What do we think here? What can I do with those right angles and the congruent angles to get to the angles I need to get to? This is where I need you to be. What do you think I have to do to those angles? Everyone agrees, this is subtraction. Basically, right angles minus congruent angles. That's how I get the prove angles. Everyone see that? I'm taking the right angles and taking away the congruent angle. Look what I'm left with. One of the prove angles. Same thing up here. I'm taking the right angle, subtracting away the given angle, and I'm left with the prove. Everyone see where we're good. So are we all in agreement it's subtraction before I move on? Okay. You're pretty solid. I know I'm going to subtract. Now I say, how many pairs of equals do I need to subtract before I write it down? 2. How many are in the given, though? Just that one. I still need to tell you another pair. And unfortunately, like it's been the last 2 days, it's not going to be reflexive here. What are you subtracting A, B, C, and F, G, E from? What did you just tell me? You're subtracting these 2 angles from the right angles. So that's going to be my second pair. I need to get the right angles equal first, then I can subtract. We good on the plan before we put it down on paper. Get the right angles congruent so I can subtract. All right, based on what we did in the last proof, can I just say those 2 right angles are congruent now? In step 2, angle FGD congruent to ABD because they're right angles. Can I do that in step 2 or no? No, I need to tell you what about them. I still need to tell you they are right angles. Because remember, I don't care what you did in the diagram. I need to see it on the paper, in the statements column anyway. So angle ABD and angle FGD are right angles. You need to tell me they're right angles before saying they're equal to each other. And then my reason, same reason I had above. Josh likes definition of perpendicular, fine. I do perpendicular lines form right angles. Now you can tell me, very next step, now you can tell me they're congruent. This is a habit you're going to get into. Tell me they're right angles, very next step, tell me they're congruent. And then that's our new reason today, all right angles congruent. Now you have your second pair of equal quantities. And now what can I do in step 4 to those? Subtract them for me. Now I can subtract the right angles from the given angles. Perfect. So angle ABD minus the angle ABC, bless you, is equal to the other right angle, angle FGD minus angle FGE, yep. Subtraction. And hey, is everyone all right? They're going to get longer. As this unit continues, the proofs are going to get a little longer, sure. 5 steps. Wow, you've grown up so quickly. This doesn't change, right? If I use subtraction or addition, next one automatically substitution. Okay, a little different. All right, we have to get off of, oh, it's always reflexive, reflexive, reflexive. Well, maybe not. Now it's right angles is my second pair. Okay, what time we get out of here? 11:40. All right, we're good. All right, I promised you a review proof. Here it is, another review proof to make sure you guys are on board. Here's why I'm doing this to you guys. I know it's right angles day. I can't just have you guys in that mode. Oh, this proof is a right angle. Next one's got to be a right angle. Next one, no. We got to be in the mode to jump back and forth here. So I'm not going to say a word about this one. I'm going to let you go on your own. Sure, if you want to talk with it about your group, sure, go ahead. That's fine. This isn't a tester quiz. But we should write nothing about right angles here because nothing says anything, a right angle exists anywhere in this proof. Everyone saw bisector, I hope, right? So you know how this would have ended. I don't know how many steps it's going to be, but at least I know the last reason is going to be halves of equal quantities are equal. To have a halves of equal quantities are equal proof, you need whatever you are cutting in half needs to be equal. I'm cutting EAB and FBC in half. Oh, that's given as equal. Perfect. I got that done. Second thing you need, and this is step 2, you need to show me you're taking half of those angles. So first one, half of angle EAB. And you cannot set it equal to half of the other angle. You need to give this a new name, a new angle name, based on the diagram. So if I take a look, half of angle EAB, I can call angle 1, or I can call GAB. But I look at the proof statement, and it's got angle 1 there. So I'll use that one over GAB. Then I'm going to take half of FBC, and I'll call it angle 2 instead of HBC. Definition of bisects or bisector. Commonly, I see halves of equal quantities in here. That's the ender. That's how I end this proof. And then step 3, angle 1 congruent to angle 2. That's halves of equal quantities are equal. Just trying to write quick here. All righty? Any questions you want to run by me for that one? Just wanted to get you out of the right angle mode for a second. All right, final thing we'll do today, let's get off of proofs for a little bit and do some algebra. Okay, because part of this unit 2, it is all proofs, but there is some algebra I sneak in. First thing, lock in here. I know it says given, and yes, I still want you to mark your diagram, but now look below. You don't see prove anymore, do you? We see find. So this is not a statement's reasons. This is just, hey, let's find the angles and we're good. All right, so do not put anything in a statement's reasons unless it says prove, prove, prove. All right, still mark your diagram though. If line RST is perpendicular to ray SQ, only to ray SQ, not ray SU, SQ. So I'm hoping you guys have your right angle symbols here. All right, perpendicular lines form right angles, and maybe you plopped in 89 degrees at angle RSU. Ready to find the angles with me? All right, first angle, the measure of RSQ, and also to justify, which means after somebody gives me the answer, tell me why it's that angle measure. If you say it's 20 degrees, why is it 20? Explain yourself to me. That's what justify is. Explain yourself. So let's go measure of RSQ. What do you got for me there? Measure of RSQ just by looking at the diagram. Who started up? 1/6, Zeev? 90 degrees. Now, it's going to tell me a reason. I'm not looking for a magic reason. It's this and only this. I will take whatever. This isn't like reasons column where it's got to be halves of equal quantities or vertical angles are congruent. I will take whatever here as far as a justification. What's your justification?
Because RSQ is given as a right angle.
I wasn't given as a right. I put the right angle there. There you go. Definition of perpendicular or perpendicular lines form right angles. All right. Be careful though. All right. That was not given. We put it there for a reason. And this is why. All right. How about the measure of QST, the next angle, measure of angle QST, that angle measure? 13. Why? Again, same reason. All right, unfortunately, though, you can't use that reason for the last angle. You're going to have to do a little different explanation for angle TSU. And honestly, this would have been the only time you needed your calculator today, maybe. So that's why I didn't have you get it for one calculation. Oh, boy. Maybe I should have had you get it, huh? I'm seeing smoke come out of some of your ears. What is that? What is that? Oh boy, ready, Aiden?
91.
91. Kid doesn't need a calculator, you just voted him out. There you go. How about that? 91. Explanation? In your own. I am not looking for anything specific, Aiden. I just want in your own words.
Because RS2 is a line and lines are equal to 180.
Okay, that's fine. I usually don't, for me personally, I don't like paragraphs, but if you wanted to write that, you could. That's fine. I'm straight angles equal 180. I'll just sum up what you just said for me. Hey, other responses? Ready? What type of angles are 89 degrees in the 91 we just found? Those are supplementary. Okay, supplementary angles add to 180. Also, vocabulary term for those two angles that are adjacent and supplementary. Linear pairs are supplementary. I would have also accepted that. All right. I'm not looking for anything specific, just something that gets the point across that you know why you put that degree measure down. All right. We're good here. You got 5 minutes, so let's get going. Hey, expect anything on these proofs. It's just not all right angles. Maybe the first one. All right, but it's not just all right angles. Expect anything. Expect anything.